Welcome to Intelligence Gateway.
Data mining and machine learning. Introduction to data mining and machine learning. Data mining and machine learning are two closely related fields that are used to analyze large datasets and identify patterns, relationships, and trends in the data. Data mining is the process of discovering patterns and insights in large datasets using statistical and computational methods. It involves identifying patterns, correlations, and anomalies in the data, and using this information to make predictions or inform business decisions. Data mining techniques can be used in a wide range of industries, including finance, healthcare, retail, and telecommunications. Machine learning is a subset of artificial intelligence that involves building models that can learn from data and make predictions or take actions based on that data. Machine learning algorithms can be classified into three main categories: supervised learning, unsupervised learning, and reinforcement learning. Supervised learning involves building models that can make predictions based on labeled data. For example, a supervised learning algorithm could be used to predict whether a customer is likely to make a purchase based on their previous buying behavior. Unsupervised learning involves building models that can identify patterns and relationships in unlabeled data. For example, an unsupervised learning algorithm could be used to cluster customers based on their purchasing behavior, without any prior knowledge of what those clusters might look like. Reinforcement learning involves building models that can take actions in an environment and learn from the feedback they receive. For example, a reinforcement learning algorithm could be used to teach a robot how to navigate a room by rewarding it for successful navigation and penalizing it for collisions or other mistakes. Data mining and machine learning are powerful tools for analyzing and extracting insights from large datasets. By leveraging these techniques, organizations can gain valuable insights into their business operations and make more informed decisions. Data mining techniques: clustering, classification, association rule mining, etc. Data mining involves a variety of techniques that can be used to analyze and extract insights from large datasets. Here are some of the most common data mining techniques. 1. Clustering. Clustering involves grouping similar data points together based on their attributes. This technique is often used for segmentation and customer profiling. 2. Classification. Classification involves categorizing data into predefined classes based on their attributes. This technique is often used for predictive modeling and decision-making. 3. Association rule mining. Association rule mining involves identifying patterns and relationships between items in a dataset. This technique is often used for market basket analysis and recommendation systems. 4. Regression analysis. Regression analysis involves identifying the relationship between a dependent variable and one or more independent variables. This technique is often used for forecasting and trend analysis. 5. Neural networks. Neural networks are a set of algorithms inspired by the structure and function of the human brain. They are used for pattern recognition, classification, and prediction. 6. Decision trees. Decision trees are a visual representation of a decision-making process. They are used for classification and prediction. 7. Support vector machines. Support vector machines are a set of algorithms used for classification and regression analysis. They are particularly useful for analyzing large datasets with many variables. These techniques can be used individually or in combination to extract insights from large datasets. The choice of technique will depend on the specific problem being addressed and the characteristics of the dataset. Machine learning algorithms, decision trees, random forest, neural networks, etc. There are many different machine learning algorithms, each with its own strengths and weaknesses. Here are some of the most commonly used machine learning algorithms. 1. Decision trees. Decision trees are a simple yet powerful machine learning algorithm that can be used for both classification and regression tasks. Decision trees work by recursively splitting the data based on the most informative attribute. 2. Random forest. Random forests are an extension of decision trees that use multiple decision trees to improve performance and reduce overfitting. Random forests work by randomly selecting a subset of features for each decision tree, and then aggregating the results. 3. Neural networks. Neural networks are a set of algorithms inspired by the structure and function of the human brain. They are used for pattern recognition, classification, and prediction. Neural networks are particularly useful for analyzing complex, high-dimensional datasets. 4. Support vector machines. Support vector machines, SVMs, are a set of algorithms used for classification and regression analysis. SVMs are particularly useful for analyzing large datasets with many variables. 5. K-nearest neighbors. K-nearest neighbors, KNN, is a simple yet effective machine learning algorithm that can be used for both classification and regression tasks. KNN works by finding the k closest data points to the new data point and using the average of their values to predict the new value. 6. Gradient boosting. Gradient boosting is a machine learning technique that works by sequentially adding weak learners to improve the overall model. Gradient boosting is particularly useful for classification and regression tasks where the data is highly imbalanced. 7. Naive Bayes. Naive Bayes is a simple yet effective machine learning algorithm that is particularly useful for text classification tasks. Naive Bayes works by assuming that each feature is independent of all other features. These are just a few of the many machine learning algorithms that are available. The choice of algorithm will depend on the specific problem being addressed, the characteristics of the dataset, and the resources available.